All right, well, this is the last video for Math 220. It's been an interesting ride here, going from having classes in person to going back, leaving for spring break, and then realizing that not able to come back due to the coronavirus. But I hope that you found this video format effective and you've been able to learn some interesting things along the way. So I want to take just a step back in this last video to remind you of where we've been and some of the big themes for the semester. So we started off in our first unit and we looked at methods of integration. The idea is, suppose you're faced with an integral, what different strategies do we have at our disposal for evaluating an integral? And then we looked at applications of integration, where we saw that we could use integrals to add up a whole bunch of different types of quantities, ranging from areas to volumes to amounts of energy to distances to a whole variety of different things. And then this last unit, we looked at sequences and especially infinite series to see how we can add up an infinite number of things like fractions or even functions and determine whether those sums will actually approach some value or whether they'll diverge to infinity. And so some of the central themes you may have noticed over the course of the semester are, first of all, adding things up. Right, integrals are just sums in disguise, and infinite series are sums as well. And so we've primarily been concerned with just addition, which makes it seem like this would be a much less challenging course than it is. But it turns out that when you're adding up a finite number of things, it's not necessarily all that difficult. But when you try to add up an infinite number of things, it can be much more challenging. And so infinity is the other central theme for this course. Adding up an infinite number of small slices for an integral is both useful for understanding what an integral means and how it's useful. And then adding up an infinite number of terms in a series was useful for things like describing change. We use geometric series, as well as approximating functions or representing them exactly using Taylor series. Okay, so infinity and adding things up were our two central themes, and the hope is that you'll walk away from this with a set of tools for evaluating integrals, for analyzing series, and a general comfort level understanding of how these mathematical tools such as integrals and series can be used to describe real world quantities. All right, well, all that you have left now is to finish up your homework and pass some exams, and I wish you all the best in those endeavors. Good luck.